day 3. Trig equations. So your homework here for day 3 is 63 through 96, every third one. So I'm going to try to finish up all the techniques today. And then tomorrow there is more after 96. There's one set where they don't give you clues in the directions. They mix them all up. And so that will be tomorrow's assignment. So no lecture tomorrow. You'll just come in and I'll have that already from the textbook and you'll work on that in class. And I'll probably, if there's not a lot of problems, maybe 8 problems or something, or 9 problems. And so I'll probably have that due at the end of class before you even leave. So it'll be an in-class assignment. And so it's just all of the types all mixed together. So as you can see, we have 4 already. Actually, 3 techniques we have looked at. We're going to do a 4th one. We're going to do a lot of problems, and then we're going to do a 5th technique. The first technique was just to isolate the trig function before you start separating. Number 2 is it was like a quadratic. Something was squared. Or maybe it was a trinomial, or maybe it was like cosine squared of x equals 1. And then you have to take the square root, things like that. So it's a quadratic-like. So you treat it like a quadratic, whatever techniques those were to solve. And then the very last example yesterday, we did it by factoring out a GCF. So it's like sine of x times tangent of x plus sine of x equals 1. You had to factor out that sine of x out of both so that you could come up with 2 equations. Each had its own isolated trig function. And so that's what we did up until yesterday. And so now today, we're actually going to use trig identities, which is kind of like what you did with verifying identities. You took tangent of x out and you put sine of x over cosine of x. Or you saw cosine squared of x and you took it out and you put 1 minus sine squared of x. You're going to use identities to trade things out so that you can solve it. And so we have, I don't know, probably about 4 problems using trig identities. And as you can see, there is the first one. 2 times sine squared of x minus 3 cosine of x equals 0. Now that would look like quadratic-like, right? Except I've got 2 different trig functions, and I can't figure out how to make 2 equations, right? It's not like this says sine squared of x minus 3 cosine of x times sine of x. Then I can factor out a sine of x, maybe isolate, and in each equation have its own trig function, but I can't. I wish, now they both said sine, but they both said cosine. Well, I can do that. What do you think I'm going to do? Yes, correct. I wouldn't want to do this one, right? You're always looking to use trig identity. The Pythagorean is the most popular one. And so you always look for the clue of the square, put parentheses around it, and then resubstitute, and now you'll have all cosines. So let's go ahead and let's try that. So I'm going to scoot it up a little bit higher. So I'm going to substitute this out. And I'm going to go ahead and distribute the 2 in. Now it's looking like a quadratic, that's a trinomial. So I want the squared term first, the one to the first power, the one with no cosine. So negative 2 cosine squared x minus 3 cosine x plus 2 equals 0. So I just rearrange the order. And if you remember when we deal with quadratics, is I never like to factor when the leading coefficient is negative. So I'm going to go ahead and also take out the negative. And I'm going to try to factor what's inside. I don't like the leading coefficient to be negative. Let's see what we can come up with. A cosine x and a cosine x. One has to be 2. One of them has to be a 1. In order to have a 2, I need a 2 and a 1 and one of them to be negative. So I think I want a positive 2 here and a negative 1. So that's correct. That's a negative cosine x. That's 4 cosine x. I'm going to get that middle term, right? So a little bit of guess and check on factoring. I know that I did not really do much teaching on guess and check last year, but we did so much technique that hopefully at some point you can start doing guess and check. You know where this trinomial comes from. It's from multiplying two binomials. And so now I can set each one please. So right now I don't have to do it that difficult way because it's just an X, right? I can think of my unit circle, but tell me something right now. Tell me something that's hopefully glaring that we didn't notice at first yesterday. Only Luis noticed it. It's larger than 1 or negative 1, right? Right? It's beyond 1 and negative 1. So you say larger. It's beyond 1 and negative 1. That is outside of the unit circle, so I get nothing from that piece. I get no solutions. This one, though, I do. Let's see. Cosine, where it's positive, is 1 and 4. And that would be, what reference angle do I want? Pi over 3, right? So x equals pi over 3 for quadrant 1. And for quadrant 4, that would be 5 pi over 3. Right? I'm going to put that in set notation. Just didn't do that. Yes?
You don't do anything with the negative?
Negative 1 equals 0. It's kind of like back in the day when you would factor. You can only have solutions where the x is, see, that equals 0, that equals 0, and that's just a number. A negative is just a negative 1. I know it's awkward. It's awkward. Your turn. It's one thing to watch me and understand. It's another thing to have your hand do it yourself. And yes, it's very similar to what I just did, of course. So ask me a question. You have a question. Anybody not ready for me to move this? Next. That 2 with cosine is not as squared. It's a double angle, 2x. So I can't figure out how I could try to isolate or have equations where I only have one trig function. I don't know how I would solve that. So the clue was this technique number 4 is use trig identities or substitute it for something else. What do you think I'm going to use here? Double angle. So the cosine 2x, I'm going to trade it up, but there's 3 different double angles for cosine, 3 different formulas. So which one do you think I want to use? The one that has cosine and sine in it, the one with only sine, the one with only cosine?
The one
with only sine, because that's what I have sitting there is a sine, right? So it is, I don't know, I don't remember. So when in doubt, because you're responsible for this, right? When in doubt, you can rederive it, right? So that's going to be cosine x, so that's 2 cosine x, I'm sorry, let's try that again. Cosine squared x minus sine squared x. And if I want the one with only sine, then that means I'm going to substitute this one for sine, right? Oh yeah, there it is. See, I don't have these things memorized. I can derive them. I remembered how to do that formula. Right, that's cosine x times cosine x minus sine of x times sine of x. Came up with that. Replace that with that, and I can rederive that. Okay, now I'm going to use that. So not only do I have sum up, I have both signs, and both of them just have an x, not one with a 2x and one with an x. I have much better hope. And now it looks like a quadratic again. Okay. So with a quadratic, I write the one with that's squared first, the one that's to the first power second, the constant. I don't want my leading coefficient negative. Now I can get started doing this. One of them has got to have a 2, and the other one's got to have a 1. They both have to have a 1 in the back, but one of them negative and one of them is positive. I want it to end up being a negative one when I add. So negative here and positive here, because it's a negative 2 sine x, it's a positive 1 sine x. I add those together, I get that. Okay. And 2 sine of x plus 1 equals 0. Sine of x minus 1 equals 0. Sine of x equals negative 1/2. I'll be able to do that. Sine of x equals 1. I can do that one too. They're both just looking at my unit circle. Let's see. Sine is 0, 1, 0, negative 1. So I get that from here. Sine. Let's see, that's quadrant 3 and quadrant 4. And that reference angle is a pi over 6, so that is 7 pi over 6 and 11 pi over 6. So my solution set is pi over 2, 7 pi over 6, 11 pi over 6. There's my solution. So ask me a question if you have a question. Anything. All right. Your turn. Very similar. Not a lot different, but still it's an opportunity. another kind. Oh, still with trig identities. This one says sine of x times cosine of x equals negative 1/2. There's not a square. Can't replace it. Or not easy. Anybody happen to see anything that I can do with the left-hand side? Or it looks close to something. Yes?
And to multiply the right-hand side by 2, and then there will be 2, and then that's the identity.
Which one?
Sine.
What?
Sine double.
The one.
Double angle of sine? So everyone find the double angle of sine formula. That is 5.3. 5.3 double angle for sine. What does double angle mean? 2 theta, right? Find sine of 2 theta. That's what he's saying. What does sine of 2 theta say? 2 sine theta cosine theta. It's almost there except for the 2. So I wouldn't mess it up if I just multiply both sides by a constant, by 2. So I'll multiply both sides by 2. Right? And we already know how to solve this. This is technique number 1. Isolate the trig function. Okay. Don't freak out about it. Sure, I won't. And it's not really a quadrant, really, is it? It's where is that going to be at? The 0, 1, 0, negative 1, right? Down here. And so that stuff underneath my pin, whatever it is, it happens at 3 pi over 2 because it's sine. I put plus 2 pi n, right? Now I'm going to pick up my pen and go, oh, it's a 2x. I'm supposed to be solving for x here. If I go any further, it's going to get too large because it's going to increase by 4 pi, right? I mean, 4 pi over 4. It's going to be too large. So there's my 2 solutions. And it's not easy to see. Every year I sit there and stare at it and I figure I can't remember how to do it and I have to look it up and go, oh yeah, that's right. Same thing, just without a negative. I know, silly, but still work through it. You try it. And you should get something like that. I'm not going to go any further because it's increasing by pi, and that will be beyond 2 pi. Here's the last one on me, technique number 4 of using identities. Now between my cosine x and sine x is actually a minus sign. Nothing squared. No matter what I try, I can't do anything. There's nothing. There's no trig identities. No matter how much I play with this, there's nothing I can do. So I'm going to have to pull out a technique that we use sometimes in Algebra 2. And what it does is then we have to check our solutions because it creates sometimes some extraneous solutions. So at the end we have to check to see which ones are our solutions. And that technique, whenever you do this, to math, trig, whatever, it's an Algebra 2 technique. Whenever you go ahead and you square both sides, you can produce extraneous solutions. That means when you're done, you have to check each solution to make sure it fits in the original equation to make sure it is true. Well, now I'm going to follow through with this just the way that it is. So remember what this means, right? Right, means this. So now what? Give me some help. Just think of verify identities. Work with the left-hand side. What can I do? I have one where? How?
Cosine squared plus sine squared.
Yep, that equals a 1. What else?
2 sine x cosine x and sine double.
Sine 2x, correct? Mm-hmm. So now I'm just going to subtract 1 from both sides, right? Oops. Right? You okay with that?
Yes, Tschida. What became a 1? Oh, okay.
So that happens at 0, and it happens at pi. Right, I have to work with both of those and put in the n equals 0, n equals 1, equals 2, etc. So let me do that. I'm going to do that here. N equals 0, I'm going to get x equals 0. N equals 1, put in 1, that's just pi. I'm allowed to have that. If I put in 2, that's 2 pi. I'm not allowed to do that. So I have 2 so far from here. Done. Next. N equals 0, put in 0, I just get x equals pi over 2. Put in 1, that would be 2 pi, so that would be x equals 3 pi over 2. And I can't go any further. If I put in 2, that's beyond. But because I squared both sides, I must check all 4 of those solutions to see if it's true or not. So I'm going to do that. I'm going to go back and get my original equation. I have to check each one of them. I'm going to check x equals 0 first. And what I'm checking to see if that's a true statement or not. Let's see. Cosine of 0 is 1. Sine of 0 is 0. Is that a true statement? No. So this is not a solution. Next. X equals pi, so that one doesn't work. Cosine of pi minus sine of pi, does that equal -1? So let's see. Cosine of pi is -1. Sine of pi is 0. Is that a true statement?
Yes.
So far I have one solution. I'm going to now try x equals pi over 2. Cosine of pi over 2 minus sine of pi over 2 equals -1. So cosine of pi over 2 is 0, and sine of pi over 2 is 1. Is that a true statement? So that is a solution. And x equals 3 pi over 2 is what I'm going to try next. So cosine of 3 pi over 2 minus sine of 3 pi over 2 doesn't equal -1. So cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is a -1. Is that a true statement? I have 2 solutions out of those 4. No, not having you try. So. Technique number 5. Use a calculator. Well, look at the problem that I gave you. It makes sense I'm going to use a calculator. So get yourself your calculator. I got mine. It says between 0 and 2 pi. Supposed to find all my solutions, all my possible x's. So is that 0 to 2 pi? Does that mean radians or degrees? It means radians. I didn't say from 0 to 360 degrees. So from 0 to 2 pi. So I got to make sure my calculator is in radians. Okay, I got it in radians. But wait, that's not isolated, right? How do I get x isolated so I can solve for that? What does switching them out mean? What is switching them out? We learned it last year and this year and tons of times. What is switching them out? What's it called? What's it called? I would like to have it isolated. I wish it said something like this. I could answer that because the unknown is isolated, right? But right now, that unknown is inside my equation. I know that's an easy one. I get that. What do I do? What's it called? Inverse. Oh, now it's isolated. Oh, now it's isolated. That's right. I switch out my x's and my y's. That's a y equals sine of x. What's my y? Negative 0.2315. Let me think about this for a minute. Now I have an inverse. I'm going to draw my cute little picture that I told you I draw every time I see an inverse for sine. All of my answers for x have to be from pi over 2 to negative pi over 2. In other words, approximately, what is that again? 1.57 to approximately negative 1.57 needs to be my answer. Okay, I'm going to grab myself my handy-dandy calculator. My handy-dandy calculator is going to tell me how to do this. Let's see. So I'm going to put in 0.2315. I'm going to, there's a couple ways to look at this. Yeah, I'll put in the negative. We'll try that. I put in the negative, and now I'm going to find the inverse sine button. Okay, I found it. This is what my calculator is displaying. Do you get something like that? Okay. Now, what if I ask you, though, to give me this angle now, the positive angle of this? What if I ask you now to give me the positive angle of this? Because I did ask you from 0 to 2 pi. This is a negative angle, which means I'm going from here and I'm going backwards to negative 0.2, right? Because going from here to here is negative 1.57, right? That's pi over 2, negative pi over 2. So it's like right there, negative 0.2. So for that terminal side, I know the negative answer, there it is. But for that terminal side, I wish I knew the positive one. Oh, you mean that name? Right. So that answer there is right here. Right there. And it's this. Because this is approximately negative 1.57. That's just negative 0.2. But I want you to tell me from that terminal side, I would like to know the positive name because I told you between here. So now come around. How am I going to mathematically do that? Add 2 pi. So we'll add 2 pi to that. And 2 pi in our calculator has to be adding 2 times pi, right? So I'm going to add 2 times pi equals, and now I get something like x is approximately 6.049566, blah, 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 right? Which makes sense because 6.28 approximately is the complete unit circle, right? And there's about a 0.23 difference, right? There's that difference. That makes sense. That makes logical sense. Hopefully that makes logical sense to you. Take the unit circle and put it in decimal form. All the pi over 2's and pi's and 2 pi's. So, yes, technically this is the correct answer, but I told you to do this. And if it tells you to the third place, then you look at the fourth place to tell the third place what to do. So that would actually be 6.050. Again, another one. I want the positive angle within one rotation. I can't answer that. It's not isolated. That means I'm just going to switch out my x and y. That means I'm going to do an inverse. Tangent is the same as sine. It has to be between pi over 2 and negative pi over 2. In other words, approximately 1.57 and negative 1.57 initially. Then I got to find the positive angle. All right, I'm going to go ahead and find that. Clear that out. 3.1044. I'm still in radians. Inverse tangent. And what I see is x is approximately 1.259168, blah, blah, blah. Let's see, it is positive. I'm good. So whatever they tell me to round it to, that's already the right answer. Because they want me to have the answer in positive in one rotation. Okay. This is probably going to be the hardest piece. Go in your textbook. There's a couple more examples. I did not do the examples in the textbook. So look at a couple more. You have to think about it. You have to realize what they're asking and figure out what to put in your calculator to get to the correct answer. Please do that tonight for tomorrow so you can ask me questions. You're set free.